Welcome to Distributed Systems course. In this lecture, that we will learn about Bloom filter. So, what is Bloom filter? This is probabilistic data structure that is used to check whether the element exists in the set or not. Normally, how we check whether the element exists in the set or not? Mostly that we will use some kind of set data structure. Then every time the element is added, then we will put the element in the set. Then again, we will check whether the same element exists in the set or not. Let's say we have 10, 20, 30. So if you want to check whether the element 10 exists in the set or not, we will check. And then if the element already exists in the set, then it will return true, otherwise it will return false. This is how it works. So set is a data structure that is most widely used to check whether the element exists in the set or not. But it's not as efficient as compared to the Bloom filter. So Bloom filter can be used in certain use cases during certain scenarios, so that we can replace the set data structure of the Bloom filter. It's more efficient. Let's see how the Bloom filter works. Let's say we have the bit vector. The bit vector is initially filled with the 0. So each bit position here initially filled with the 0. So the size could be, let's for example in this case that we have a size from 0 to 255. It's a 256 size bit vector. So Bloom filter is nothing but a bit vector. So that whenever you want to check whether the element exists in the set or not, we don't store the element here, but we will use a different mechanism. So how we use a different mechanism here? We will apply hash function here. So when 10 is added to 10, 20, 30, when we add, how we add those elements to the Bloom filter? First, we will apply k different hash functions. Hash function is hash of 10, hash 1 of 10 to hash k of 10. We will apply k different hash function to the each individual elements. By applying k hash different function, we have a k different values. Then we can mark those values. Find the bucket in the bit vector. Now for each position that we will flip the bit into 1. For example here 1. Let's say here we'll flipping it 1. So we have k different hash function, which means that we have 3 different hash functions. K is equal to 3. We will apply on number 10. Same way we will apply on number 20, and we will apply on number 30. All for the corresponding bucket that we will flip the bit into 1 in the bit vector. So now the next time when you check the element the k, so we will do the same. We will compute the k different hash function and the bucket number. Then we will check whether all the elements are 1. If it is 1, then it will return the element exists in the set. If there is 0, then which means that the element does not exist in the set. So this is how the Bloom filter works. So how it is different from set? So some cases, for example, with all the element are positioned in the bit vector are already filled up, because for example we are adding more elements, so at certain point of time the elements in the bit vector will be filled up. I mean, all the elements in the bit vector will be 1, so there will be no space here. So in those cases, that for example we are adding one element 1001 or any element, we will apply the k-hash different function, then we will try to set 1. Whenever that we want to check whether the element 1001 exists, we will apply the k-hash different function, and we will find whether the element exists in the set or not. Since all of them are already filled up, it will return true, but the element that does not already exist in the set. So certain cases, during certain scenarios, it will return a false positive, which means that it will tell the element that is not added to the set. It will tell that element that exists in the set. So in order to properly resolve this, that we can vary the size of the bit vector, or we can expand the size of the bit vector. In those cases, that we can reduce the false positive. Here the error rate, mostly the error rate will be 0.1 or 0.01, so we can configure this. So in this way, that we can reduce the error rate by maximizing the bit vector. If we reduce the bit vector, then the false positive will be higher, the error rate will be higher. So it is used in certain scenarios and applications. For example, if you are building some kind of recommendation, every time the user visits a product in an e-commerce site, that we have to tell the user, we have to suggest that product, recommendation product that are user more likely to buy. So how can we do that? We can use a set, but BlueFilter is more efficient. Even if the error rate is 0.01, false positive returns some values, so it will not affect the application. So how it is used? For example, user visits the product, so the product ID is applied k different hash function, and the bits are flipped into 1. The next time the user comes, visits another product, it will do the same. So when the next time user comes, by visiting another product, we can check whether the user already visited the product. If he already visited the product with all the bits in the bit vector are set, then the recommendation, we can say that the recommended product that the user will likely to visit in future, or will likely to buy. So even if it returns a false positive, it will not affect the application. It will not affect the application. So we can recommend 0.01 or 0.1% false positive to the user. So this is how the Bloom filter works, and this is how used in most during certain scenarios in a distributed databases, in application, etc.